Hello class, in this video I'll be showing you an application of inflection points. Let's begin. Sometimes an inflection point can represent a point of diminishing returns. This is the point where adding one additional unit results in a smaller and smaller increase in output. Now let's take a look at an example. Let R of X model the revenue in thousands of dollars of a small business where X represents the amount spent on advertising, also in thousands of dollars. Find the point of diminishing returns. To find the point of diminishing returns, we're going to need to find an inflection point. This requires the second derivative. The second derivative of this function is 4/27 times the quantity negative 6x plus 132. To find the location of a potential inflection point, we need to determine where the second derivative is equal to 0 and where the second derivative is undefined. So I will start by setting the second derivative equal to 0. That will look like this. Now I'm going to set negative 6x plus 132 equal to 0. That will look like this. To solve for x, we're going to subtract 132 from both sides and divide both sides by negative 6. So x is equal to 22. Since 22 is within the domain of this function, there is a possible inflection point at x is equal to 22. However, we will not know until we determine if the second derivative changes signs at x is equal to 22. Now to determine where the second derivative is undefined. Since the second derivative is a linear function, it is defined for all values of x, which means that the second derivative will never be undefined. Therefore, the only potential location of an inflection point is at x is equal to 22. Now to create a number line. On this number line, I included 22 because the second derivative at 22 is equal to 0. I also included 0 and 25 because x must be between 0 and 25 inclusive. Now there are two intervals to test. The first interval is between 0 and 22, and the second interval is between 22 and 25. What I'm going to do now is choose a number in each interval to determine the sign of the second derivative. That will look like this. So the second derivative is positive when x is between 0 and 22, and the second derivative is negative when x is between 22 and 25. What this means is that at x is equal to 22, there is an inflection point, and hence that is the point of diminishing returns. To find the coordinate where the point of diminishing returns occurs, we will substitute 22 into the original function and find the value of y. We will do this in Desmus. So I've entered the function into Desmus. Now all that's left to do is to evaluate this function for when x is 22. So when x is 22, the function is 6,517.92593. Before I box this answer, I'm going to show you a table that verifies that x is equal to 22 is the location of the point of diminishing returns. If you look at the chart, in the column on the left, we have values of x ranging from 19 to 24. In the column on the right, we have all of the output values of R of x. Notice that as x increases, the revenue also increases. However, if you look at the values of x before 22, revenue is increasing at an increasing rate. If you look at the values after 22, revenue is increasing at a decreasing rate, which means the point of diminishing returns occurs at x is equal to 22. And we are done.